This lecture is a little mini extension of our discussion on public goods. Here, we look at public goods using mathematical equations. We can see from our graphical representation of public goods that we have to add vertically the willingness to pay of each individual. So when we're locked at a quantity of 4, we say that the first individual is willing to pay 6 and the second individual is willing to pay 9. And so what we should end up with is a willingness to pay of 15 for those 4 units. Well, when we look at this as a mathematical equation, what we can see is that person A, their willingness to pay, their benefit from this public good, the marginal benefit, is equal to a mathematical equation of 12 minus 0.75 Q. Person B's marginal benefit curve here could be represented as 10 minus Q. Now what we have to do is we have to think about the societally optimal quantity of the public good. So what we're going to have to do is we're going to have to figure out how you mathematically add vertically. So how do you add vertically with our equations to get the same result that we got with our graphical analysis? So what you can do is you can look at the marginal benefit curve, and what you can do is just simply add these together. 10 plus 12 will give us this 22. This minus 0.75 Q minus Q, you add those together and you're minus 1.75 Q. That will give us our aggregate willingness to pay. This works here in very simple terms, and when we set it up, equal to MB equals then the rest of the equation. So similar to an inverse demand curve. When we get that, we end up with the right aggregate willingness to pay, or the total benefit, the total marginal benefits curve. We can see that this actually does work out by just simply plugging some numbers into A and B's marginal benefit curve equation. So think of the quantity of 0 here. If we throw a quantity of 0 into A and B's marginal benefit curve, right, their total, we throw a 0 into here, what then we end up with is 22 minus 0, which should equal 22. So our marginal benefit at 0 is 22. Well, at 0, B is at 10, A is at 12, and guess what? A and B together, 22, right? So that one checks out. We could do the exact same thing, but now for a quantity of 4. Throw 4 in here, and you end up with minus 7 once you multiply that through. So you end up with a marginal benefit of 15. At a quantity of 4, we should have a total benefit of 15. And lo and behold, that's what we have, because person B valued it at 6 and person A valued it at 9. 6 plus 9 gives us this 15. So this equation checks out. So let's look at this question using these two individuals. These two people are considering the purchase of a public good. Person A has a marginal benefit, as we stated from the graph, of 12 minus 0.75 Q. And person B had a marginal benefit of 10 minus Q. We want to know what the optimal quantity of this public good is in this two-person society if the marginal cost is given as equal to 3.75 Q. So what we do is we take each individual's marginal benefit equation. So in this case, we took person A and person B. We take their marginal benefit curves and we add them together. As we said, take the first units, add them together, and we get the 22. Right. Take the second part, add them together, and you get the minus 1.75 Q. So from this, now we have the society's total marginal benefits curve here, right, of 22 minus 1.75 Q. We take that total marginal benefit curve and we add in the marginal cost to the equation. Where society is optimally producing is where our total marginal benefit equals our marginal cost. We now can add in our marginal cost. Our marginal cost was given to us at 3.75 Q. We set them equal to each other. So we take our marginal benefit, swing that down. We take our marginal cost, swing that down. So we have 22 minus 1.75 Q is equal to 3.75 Q. We can reduce this equation as we only have one variable. We can reduce that solution down to 22 equals 5.5 Q. And from there, we can solve to find the optimal quantity for society, which is Q equals 4. So the answer to this would be Q equals 4 would be the optimally produced quantity for society. This does not mean it's where we end up, but this would be the optimal amount if we could get there. When we look back at our graph, this is exactly what we show. We have the societally optimal outcome being at a quantity of 4. Willingness to pay of 15 gets us to that, right? Given the marginal cost curve that we had, and given the individual demand curves, the individual willingness to pay curves that we had, when we add those up, we get the same outcome graphically as we do mathematically, as the math is just a different way of expressing the graphs here. And so we end up with the same outcome. We kind of have checked our answer. Here's an example, question number 2. You can go ahead and try this one, maybe pause the video after you see this slide here, and then try and solve it, but I will provide the answers following this. The question is that we have 20 people who are considering the purchase of a public good, and each of them has the same marginal benefit curve. The curve that they all share, that they each have, each individual has this curve of their marginal benefit, their individual marginal benefit equals 100 minus Q. And we're asking, what is the optimal quantity of the public good in this society if the marginal cost of providing the good is constant at 40? So we have 20 individuals, each with the marginal benefit curve of MB equals 100 minus Q, and a constant marginal cost of 40. What is the societally optimal quantity of this public good? Well, what you can do is follow the same process. Take each individual's marginal benefit equation, which again was given to us as 100 minus Q. Add all 20 of them together. So we add 20 times this 100. So we do 20 times the 100. And what you should end up with is 2,000. And you do 20 times the Q, because we have 20 individuals, so we're adding 20 of them together. And you get 20Q. Take this total marginal benefit now that we have of this 2,000 minus the 20Q that we just solved for, and we take the marginal cost that was given to us of 40, marginal cost equal 40, it's constant at 40, the quantity doesn't change it at all. And we can set these equal to each other because we want the marginal benefit to be equal to the marginal cost if we are going to be at the societally optimal outcome. So we say this 2,000 minus 20Q has to be equal to 40. We can reduce these equations down by simply subtracting 40 from both sides and adding 20Q to both sides, and we get 1960 equals 20Q. And from there, we can solve and find the optimal quantity for society. And in this case, quantity equals 98. So there we have the basic idea of public goods math and a simple introduction to the concepts that should get you rolling through any basic type problem of public goods using mathematical equations.